Hello, welcome back. Okay, this is our new lesson for today. This will be done in the future on the right side. So let's go ahead and cut that and put the right side in our pocket page. Keep it nice and safe. Where's the pocket page? Aha. Okay. Simplifying radicals. So kind of changing it up from doing quadratics. We are now working with radicals, which is like the square root symbol. So this is going to be due Wednesday by 4. We don't have any school on Monday, and I'm trying to change things up and not give out so many 75s. So if you turn this in by Tuesday at midnight, I'll give you extra credit, but you will have until Wednesday at 4 to get full credit. And then I'll post the answers, and if you turn in after that, you'll get the 75. Okay, simplifying radicals. This is very useful for when you go to geometry. There's a chapter where you have to know how to do this. So I thought it would be nice to go over today. So like I said, the square root uses the radical symbol. So it's nothing new to you guys. The number under the radical is called the radicand. So you kind of want to know these words for whenever we go to solve these problems. I might be using these words. So for example, this 8 is the radicand. The index is this number out here in front of the radical. The index in square root is 2. So you don't usually see the 2, but for square root, there's like an invisible 2 there. However, the index can be any number. So for example, the index in a cubic root is 3. So this would be a cubic root. This would be asking what number times itself 3 times would equal 8. And that would be 2. 2 times 2 times 2 is 8. So the index can be different. For right now, we're going to keep it at 2. We're just going to be working on square roots. Numbers that multiply by themselves to make the radicand. So to simplify a square root, you will want to find the biggest perfect square that can be divided into the radicand. So I went ahead and found this on Google for you guys to remind you what perfect squares are. It is this column and this column, in case you did not print it as colors, is the purple columns. So when we square 1, we get 1. When we square 2, we get 4, and so on. So these are called the perfect squares. You also have them in the very back of your notebook. So if you look at your multiplication chart, the diagonal of that chart is all the perfect squares. So 12 times 12 makes 144. If you were to square root 144, you will go back to 12. So that these are also the square roots, or the perfect squares. Okay. So this is the most useful information. To simplify a square root, you will want to find the biggest perfect square that can be divided into the radicand. So this is just all we're doing today. For example, we want to simplify, leave the answer in simplest radical form. So we're going to take the radicand, 252, and start dividing it by these numbers until we find the biggest one that will divide into 252 without any decimal, without any opportunity for another number to be divided in. So you're really just going to need your calculator. Here, I'll use our FSA calculator. And we're just going to start dividing 252 by perfect squares. So let's start with 4. That gives us 63. So we know we need a way bigger number to divide into 252, bigger than 4. Let's try 9. Again, that gives us 28. We're looking for numbers to be like 5, 6, 7 after we divide. So let's do 252. We did 4, we did 9. Let's try 16. Divided by 16. That gives us a decimal. Not good. 252. Our next perfect square, let's try dividing it by 25. Another decimal. Let's divide 252. We did 25. Let's try 36. Okay, that gives us 7. None of the other perfect squares can be divided into 7. 7 is not divisible by 4 or 9. So this one works. We divided by 36. So that means we can break this apart into the square root of 36 and the square root of 7. Because we said 36 times 7 is 252. Now, since we divided by a perfect square, we can square root this number. The square root of 36 is 6. And then we will just leave the square root of 7 because it's not a perfect square. It would be a decimal. So this would be the final answer. 6 radical 7, or 6 times the square root of 7. Okay, I'm going to do the odds and you guys will do the evens, so don't freak out if you're not understanding it. All we're doing is dividing by these perfect squares, finding the biggest perfect square that will divide into these numbers. So let's try 80. 80 divided by 4 gives us 20. Now that's still a pretty big number, so let's check a bigger perfect square. 89 doesn't go into 80, it goes into 81, so it's not going to work here. So let's skip to 16. We divided by 4. Now let's try dividing by 16. 80 divided by 16 is 5. Okay, so that means we can break this apart into the square root of 16 and the square root of 5. There's no other number that can divide into 5, so we know that we found the biggest perfect square that will go into 80. Okay, now we can simplify. The square root of 16 is 4, and we don't know the square root of 5, so we're leaving it at square root of 5. So that would be your final answer. 4 radical 5. Okay, let's try 45. The square root of 45. Let's start dividing. 45, I already know it's not divisible by 4 because it ends in 5. It's an odd number. Let's divide it by the next square root. Let's divide it by 9. Okay, 9 and 5. There's no other number that divides into 5. So we have the square root of 9 and the square root of 5. 9 times 5 is 45, so this is equal. We know the square root of 9 is 3, and we will leave the square root of 5 as the square root of 5. So we're going to leave our answers in simplest radical form. We do not want a decimal, we want a radical. So we don't know the square root of 5, it's not a perfect square, so we leave it like that. Okay, the numbers are starting to get bigger. Let's try 147. So I'm going to start by dividing by 16. Okay, that's not going to work. That gives us a decimal. 147 divided by 25, still a decimal. 147 divided by 36, decimal. Let's try 147 divided by 49. Okay, so we divided by 49 and we got 3. 3 is a small number. No numbers divide into it. So this is going to work. We divided by 49 and we got out 3. We're leaving them under radicals because it was originally a radical. So square root of 49 is 7, right? From 49 to 7. 7 squared makes 49. And we don't know the square root of 3. It's not a perfect square. So this would be the final answer. Okay, 242, getting even bigger. So I'm going to start by dividing. I feel like I can jump down to 64. Let's try that one. 242 divided by 64. Decimal. 242 divided by 81. Decimal. 242 divided by, I'm going to skip 100. I know 100 won't go into it. Let's try 11 squared, 121. Okay, so when we divided by 121, we got out 2. 2 is a small number. No other perfect square can be divided in, so that will work. 121 times 2 is 242. The square root of 121 is 11, and we do not know the square root of 2. It's some really long decimal, so we'll leave it like that. Okay, so hopefully that was clear. If you have questions, message me, let me know. You're just dividing by the perfect squares, so the numbers in the purple columns, until you can't divide by any other number, until you get a 5 or a 3 or a 2, number that can't be divided by a perfect square. Like I said, this will be due by Wednesday at 4 p.m. If you get it in Tuesday by midnight or before I wake up in the morning, I'll give you extra credit. So that way I can go ahead and grade it and not have a bunch of things coming in at 4 p.m. Okay, have a good 3-day weekend. Bye.